Hello and welcome to yet another video of Cornerstones of Math. On the xy plane, consider a unit circle with its center at the origin O. On this unit circle lie points P1, P2, P3, and so on, all the way up to P100 in this order counterclockwise, which divide the circle into 100 arcs with equal length. Let P100 be 1, 0, and angle P100 OP1 as theta. Then of course these angles also must be O theta. Also, since we divided the circle into 100 arcs, we know that this theta equals 2 pi over 100. What are the values of cosine theta plus cosine 2 theta plus cosine 3 theta plus so on plus cosine 100 theta? And sine theta plus sine 2 theta plus sine 3 theta plus so on plus sine 100 theta. Alright, now I am going to solve this problem. First, let us think about the coordinates of these 100 points. Starting from P1, you can easily understand that its coordinates are cosine theta, sine theta. Now some of you might think that it's because this length is cosine theta and this length is sine theta. And although it is kinda true, the more precise statement is because they are the very definitions of cosine and sine by the so-called unit circle definition. Let point P, which is x, y, be the intersection point between a half line with angle theta to the positive x direction and a unit circle. Then the trigonometric functions are defined as sine theta is defined as y, and cosine theta is defined as x, and tangent theta is defined as y over x, which is sort of an expanded, generalized definition compared to the definition using a right triangle. The important thing here is that these coordinates x and y preserve their signs, which means that whenever they are on the positive side of the axis, we use positive values, and when they are on the negative side of the axis, we use negative values. In this way, we can calculate the values of trigonometric functions for basically any general angle theta, as illustrated in these examples. So back to this figure, if we move on to P2, its coordinates are cosine 2 theta, sine 2 theta. Similarly, we have cosine 3 theta, sine 3 theta for P3, cosine 4 theta, sine 4 theta for P4, and so on. And finally, this point P100, which is 1, 0, can be expressed as cosine 100 theta, sine 100 theta. So these are the coordinates. Next, let's talk about the symmetry. Due to the nature of dividing a circle into 100 arcs with equal central angles, points P1 and P51 must be symmetric with respect to origin. You can also use the fact that since theta has this value, rotating 50 theta means rotating pi. Anyway, this symmetry means that the sum of their x coordinates must be 0, so we have cosine theta plus cosine 51 theta equals 0. We also have y coordinates, but let us first consider only x coordinates for now. Next, points P2 and P52 are symmetric with respect to origin, so the sum of their x coordinates, cosine 2 theta plus cosine 52 theta, is 0. And you can see that we can go on and on until we reach two symmetric points P50 and P100, which give cosine 50 theta plus cosine 100 theta equals 0. Therefore, if we add them up, we obtain cosine theta plus cosine 2 theta plus so on, all the way up to cosine 100 theta equals 0. And similarly, if we consider the sum of y coordinates, we can obtain sine theta plus sine 2 theta plus so on, all the way up to sine 100 theta equals 0. So we have obtained the answers, but I would like to remind you the limitation of this method. We have used the symmetry that arises only if n is even. And this makes you wonder, what about the case when n is odd? Can we prove the similar identities for general natural number n?